we're going back to something that I said the other day when it comes to trigonometry. While trigonometry by definition is the relationship or the study of the relationship between sides and angles in a right triangle, the purpose of trigonometry is to find missing sides and missing angles in triangles, in situations where you have a mixture of sides and angles. Did you notice we haven't solved for angles yet? If you didn't, hey, we haven't solved for angles yet. The reason we haven't solved for angles yet is because of where angles go in trigonometry. When I write a trig ratio, and you don't have to write the stuff I'm writing across the top if you don't want to, but when I'm writing trig, if the angle is unknown, the unknown goes right here, and it's equal to a fraction that'll have numbers in it. It looks something like that. But if you think about how we get x alone, for example, if I give you x plus 5 equals 7, and I want to say solve for x, in other words, get x alone, what are you going to tell me to do?
Minus the 5.
Minus the 5. Why did you choose minus?
Because if it's a plus, you always do minus.
The opposite of plus is minus. 4x equals 16.
Then you just divide the 4 by 16.
16 by 4, but yes.
Yeah.
Or x squared equals 25. To undo the square, you get the square root. Essentially, with each of these, you had to have its opposite operation in order to get x alone from whatever's stopping it from being alone. Stopping x from being alone here is sine. I haven't taught you what sine's opposite operation is yet. That's why we haven't solved for angles yet.
How did you get x squared equal to 25?
It was just a problem I came up with.
Okay.
These are all unrelated. So, if you need to get rid of trig to get the angle alone, that's where what's known as inverse trig comes from. It's the opposite operation of regular trigonometry. Inverse trig solves for angles. So, first things first. When it comes to working with inverse trig, we have to be able to just do some basic evaluation. The basic evaluation is the can you plug it into the calculator type of thing. Inverse trig. On your calculator, find your sine, cosine, and tangent buttons. Kind of in the middle of your calculator on all the different types of calculators?
Yeah.
Now, look at the secondary button to them. The little writing above the button. Do you see the sine with the little -1 and the cosine with the little -1 and the tangent with the little -1?
Yeah.
Look at your calculator.
Yeah.
It's going to be easier to see on yours than on mine. That's what inverse trig looks like. Is it looks like it's got a little exponent of -1. It's not an exponent. It's a symbol that means inverse. That's a symbol, it's not a -1. It's an inverse symbol. Meaning it's the opposite of sine. Cosine inverse, opposite of cosine. Tangent inverse, opposite of tangent. So, first thing we're going to practice is just evaluating using our calculator, which means just typing this into our calculator. I want the sine inverse button. What do I have to click on my calculator first?
The second.
Either the second or the shift, depending on if you have a TI or a Casio. Click it. Now, to get sine inverse, I click the sine button. And I should see the sign with the little -1. Now, inverse trig, do you notice that my TI opens a set of parentheses here?
Yes.
Casios do not, depending on which Casio you have. I will tell you right now, in inverse trig, those parentheses are hugely helpful. There are times where you can get away without them, but most of the time, if you see a sign with a little -1, it should immediately be followed by parentheses. That's going to save you a lot of headaches. And guess what I type in next? The number 0.4848, close the parentheses. Enter. What do the instructions say to round to?
The nearest degree.
The nearest degree, in other words, the nearest whole number.
28.
Nearest whole number is not 28, it's
Oh.
29. 29 degrees. That's what inverse trig gives you. Gives you an angle, gives you degrees.
You want us to like show our work on this?
On the first three, there's no way to show work.
Okay. So you don't want us to like put like the number that we are rounding up from?
Nope.
Okay.
Cosine inverse 3/4. Second, cosine button. We need parentheses here. If you do not, this is going to be one of the problems that if you do not put parentheses on it, the calculator is going to give you the wrong answer. In fact, the calculator is going to yell at you and tell you it can't do it. You need the parentheses. Otherwise, all it's doing cosine inverse of is the 3, not the 3/4. Speaking of 3/4, how do I put 3/4 into a calculator?
The ABC.
Without the fraction button, it's 3 divided by 4. The fraction button sometimes gets messy with trig. So I would just use a divide symbol. Sometimes it works, sometimes it doesn't. Round it to the nearest degree,
41.
41 degrees. Tangent inverse 8/3. What's the only thing I need to make sure that I'm careful with?
The front.
Put parentheses. Everything else, generally speaking, pretty self-explanatory. The only other thing is make sure you're doing inverse tangent, not regular tangent. Round it to the nearest degree.
69.
69 degrees. Evaluating. Do you think you could type things into a calculator?
Yeah.
I think so too. Now, more commonly, you're going to be solving. The most common way you're going to see it is with a picture. If I don't give you a picture, the other option is it will already give you the equation. If I give you a picture, you end up writing these equations. Where's the variable in this problem? L. And if it follows trig, if it goes trig and then that thing, what does that thing have to be? A side or an angle? Has to be an angle. Trig is always of an angle. That has to be an angle. And if you're finding an angle, you're going to end up using inverse trig. Because I want to get L alone, which means the sign needs to go away. The only way you get rid of things is their opposite operation. Sign's opposite is sine inverse or inverse sine. Now, going back up here real quick. The location of where I put things when I'm doing opposite operations sometimes can make a difference. For example, so I've got an x plus 5 right there, equal to 7. Now we said we do minus 5, which I agree with wholeheartedly. But if I had written it like this, would it have been the same thing? No. No different than if I have 4x equals 16, and instead of doing divide by 4, I do the 4 above and the divide symbol. Is it the same thing? No. 4 divided by 16 and 16 divided by 4 are not the same. No different than if I put the square root symbol right here, would it mean anything? That's the one that's the most ridiculous. Inverse trig, just like regular trig, goes in front of things. So, if my goal is to get the L alone, I'm going to do the opposite operation of sine, which is sine inverse, and I'm going to put it in front of things. So I'm going to write sine inverse, parentheses, and in those parentheses are whatever was on that side of the equal sign, which was sine L. Equal sign was here. If you do it to one side of the equal sign, you do it to the other. So I'm going to do sine inverse, goes in front of things. In parentheses is whatever was on that side of the equal sign, which was square root of 5 over 7. Now that looks ugly, and I'll give you kind of a shorter way to write it out here in a minute. Or shortly, I should say. Not quite immediately. But I want to talk about this side real quick. On the side that has the opposite operations together, you know what to do, because what do you do when you have these opposite operations of plus 5 and minus 5 right here? What happens to them? Cancel. What about the 4 and the divide by 4? The square and the square root? Cancel, which means sine and sine inverse will cancel. You will be left with L on that side of the equation. On the other side, you technically have the sine inverse of square root of 5 over 7. As ugly as that looks, is calculator friendly. Assuming you're careful. I do have to be careful when I'm typing it in because of that square root. Sine inverse, open parenthesis, square root. Now, square roots on your calculators will do one of two things. If you got a fancier calculator, it'll do what mine does, which means everything that I type right now ends up underneath that square root. Do I want all of that underneath the square root? No, especially what I typed. What do I want under the square root? The 5 only. So if you got one that types everything under the square root, you type that 5, and then you need to click the right arrow so that the square root stops. If you have one of the little TIs, or you have an older style calculator like my TI-83s, when I do sine inverse of square root, it opens up a set of parentheses. I got to put the 5 in, and then I have to close that square root before I do the divide. And then I close the inverse trig. Close your inverse trig. It says round to the nearest degree. $19. Okay. Make a pass, but yes. Okay, cosine of A is equal to 0.731. Where's my unknown? An angle. When it's angle, I use what? Inverse trig. What is cosine's opposite? Inverse cosine. That always goes in front. Never put it out back. It doesn't mean anything behind things. It has to be in front of things. If I do it to one side, I do it to the other. On the left side, what's happening? Cancel cosine inverse and cosine. They die a painful death, leaving me with A. Yay? You're yaying to death?
Of the math.
A death of math, fair. Like, it hurts my heart, but you be you. What is cosine inverse of 0.731? Rounded to the nearest degree. Type it in your calculators.
Do I, so like, do I hit the square root and then put the numbers?
There's no square root on this one. This one's just 0.731. You do the square root only on the ones that had the square root.
Just to the nearest trig square.
You did sine inverse. We're doing cosine inverse.
Oh.
Okay, we get 43 degrees. Okay, last one that looks like this before we're going to change it up a little bit. Tangent of W equals square root of 365. Am I solving for a side or an angle? Angle, because it's unknown is right there. And therefore we do inverse trig. Specifically inverse what? Tan. Inverse tangent, technically. I don't write all of this out every single time. That gets a little bit tedious. I tend to do this. Since it has to go in front of things, and there's typically not enough room to write it immediately in front, I just do this. That way it's kind of as in front as I can get it without writing over the stuff. Those will still cancel out. And W is tangent inverse of square root of 365. In fact, I don't even necessarily always write this way. I'll be honest. That we type into the calculator. Tangent inverse, don't forget the square root this time, of 365. What do we get? 87. 87 degrees. Okay. More often than not, you're not going to have the equation written for you. More often than not, you're going to have problems that give you a picture, which, by the way, we're going to change something real quick about 2 of these pictures. Problem B, scribble this off. Put a little X degrees right there. Problem D, we're going to do the same thing. Get rid of where it says angle B and put a little X degrees right here. Okay. These problems say find the indicated angle measure, round your answer to the nearest degree. Now, how they indicate angle measure is going to be one of 2 ways. Option 1, they're going to say the name of the angle up top. Can we put the laptop away for now, please? Option 2, they're going to put an X degrees in one of the corners. Starting with question A. We're solving for angle P, which means angle P, which is right here, is our angle of focus in this problem when we talk about opposite adjacent hypotenuse. Yes? Absolutely. Solving for angles starts off a lot of the same way as solving for side lengths. You focus in on what angle you have and you label your opposite, your adjacent, and your hypotenuse. I always start with the hypotenuse. Is the hypotenuse the 19, the 13, or the blank one? Hypotenuse is across from the 90. Hypotenuse. Which one's opposite, the blank or the 13? Opposite goes across from the angle of focus, so that's the opposite, which makes the 13 the adjacent. What's the memory trick for trig again?
SOHCAHTOA.
How do I spell SOHCAHTOA? Kinda, yeah. One of the sides is not going to be helpful to you because it has nothing marked on it. Which one's not helpful? Opposite. Which means I've got adjacent and hypotenuse to work with. Adjacent and hypotenuse? Cosine. Cosine. What always immediately follows the trig? The angle. Always the angle. If you know it as a number, put the number. If you don't know it as a number, put its name. What's its name? P. If it had a variable in the corner, you'd put the variable. Cosine of P equals AH. 13 over 19. Adjacent divided by hypotenuse. You're solving for an angle. You're trying to get rid of cosine without moving the angle because the angle's got to stay put. To get rid of cosine without moving its angle, inverse cosine. Again, I tend to put it in front, kind of at an angle. Saves myself some writing because cosine and cosine inverse will cancel out. P will be whatever cosine inverse of 13/19 is. And I type it into my calculator. I think it's 40 something.
No, you said 47.
Did you do parentheses? Did you do inverse cosine? Did you type it in the order that we're supposed to type it in? Did you change your 19 to a 9?
You're neat.
Cosine inverse of 13 divided by 19. 47
47.
degrees. Okay. Moving on. Problem B. What am I solving for? X. That's what I'm focusing in on. Which side's the hypotenuse? 23. Opposite is the 16, which means that's the adjacent. Not helpful to us. Which of those sides has not got anything on it? The adjacent, the A. Don't care about you. Okay, I'm hearing a lot from the same people, so I'm going to my name cards. Hey, make a pass. Mariana, which of our trig ratios uses the hypotenuse and the opposite? Which of these works with H and O? The first one, the S. And the S stands for? Sine. If you forget, can you look at your calculator and find the 3 buttons? And find which one starts with an S? Yeah, because while I want you to say sine, cosine, and tangent, when you're writing it on the paper, are you saying it aloud? You don't have to. Maddie, what immediately comes after sine? The angle, which is angle D, or I would prefer when it gives you x degrees just to put the x, because sometimes it won't give you D. But if you did put D, I wouldn't hold it against you on this one. That would be perfectly acceptable too. Equals area. What's the fraction gonna look like? 16 over 23. Beautiful.
Aaliyah, how do I solve for x?
Perfect. Put them in parentheses and do not. No, you don't. And put the sine inverse in front. On the left side, sine and sine inverse are canceling. X equals whatever sine inverse of 16/23 is. Avery, what is sine inverse of 16/23? $44. Okay. Question C. Solve it for angle B. Jackson, how do I start the process? We're not there yet. I need some labels.
Oh yeah, label the cross hypotenuse.
The 19, the 22, or the blank one is the hypotenuse.
Blank.
Okay. What about opposite and adjacent?
19 is opposite. No. Adjacent.
Solve it for B, so 19 is adjacent. That's opposite.
We cross out the hypothesis, or
Hypotenuse is not helpful, so we can cross it off. We can focus in on adjacent and opposite. Leah, which of our trig ratios uses adjacent and opposite? The TOA one. And the T stands for tangent. Or if you at least know it's TAN, you're good. Eli, what comes immediately after tangent?
the fraction, the fraction.
Not yet. Fraction has to go on the other side of the equal sign.
It has to parentheses.
Trig, angle. What angle?
Angle.
The angle of focus,
Oh.
which is our angle of focus on this one.
Yeah.
B. And then it equals a fraction. Kellen, what's the fraction going to be here? You're fine.
the O and, the O and A, and then, but the O goes on top and the A goes on the bottom.
Good. So 22 over 19. Zion, how do I get B alone?
Parentheses. Do that thing where it cancels out.
Tangent with the little -1. Tangent inverse. Be careful. Cancel, cancel. B is equal to whatever tangent inverse of 22/19 is. Max, what do we end up getting for that? Yeah, type it back into your calculator real quick. My goodness, I have
49. Sorry, I typed it right. I just forgot the part. I accidentally did subtraction.
got it. I'm glad you typed it in right because I typed it in wrong 3 times in a row. Okay, last problem. Same general idea. One slight difference on this problem. What are we solving for on this one?
X.
The x. That's our angle of focus. Our hypotenuse is 15. Which side's the opposite? The 9. Makes that one the adjacent. Do you see what's different about this problem? It has all 3 sides. Which means It just means that you're not limited on which trig ratio you can use. Because you have opposite, adjacent, and hypotenuse. You're still solving for an angle. So you're still mixing together sides and angles, which means you're still doing trigonometry. But you can make a choice. Which side length you want to ignore. If one of them was ugly, I'd ignore it. Are any of them ugly? Not really. So make a choice. Do you want to ignore the 9, the 12, or the 15?
The 12.
Sure. If we ignore the 12, we're left with opposite and hypotenuse, which is which trig ratio? Opposite and hypotenuse is? Sine. Sine of what? What immediately goes after the sine? The angle, and the angle in this case we called? X. You technically could call it B on this one too, but I prefer the X. Equals, is it 9 over 15 or 15 over 9?
9 over
9 over 15. If your calculator ever gives you an error, make sure you typed in the right numbers, make sure you type them in the right order.
So not important for them to break that down to the lowest common fraction at that point?
No.
Okay. I didn't think so.
That's for, just for when we're typing out or writing out just the fraction itself. That's when you get 37 degrees. So, shockingly enough, I have a worksheet for you. I'm pretty sure I told you at the beginning of chapter 9. How many book assignments are in this chapter? None. Okay, today is Wednesday, so our homework's due on Friday. Friday is the 4th. It is the 9.5 worksheet. Make sure 9.4 worksheet 1 is getting turned in.